Good morning, good morning, good morning, good morning, everybody. Welcome one, welcome all. Here we are. It's office hours for Unit 2. I am, as always, your guide in your data science journey, Nicholas, and I am so excited to see everyone here. How is everybody doing? What's new? What's exciting in your worlds? I see Aman is here from Pakistan. Florin is here. Unsun is also here. Well, good to see you. Imar is back. Good to see you. John is here, Emmanuel and Innocent, all my most dedicated students. So glad to see you guys are here. Florin wants to know if I know that Florin knows English. And yes, I know. And I know you know I know. English and German and Romanian, right? And let's see here. Dimitri is here. Welcome, Dimitri. Julius, so good to see you. Aaron, good to see you as well. Fantastic. I've got my coffee here. I'm ready to go. Oh, look at that. We now have two Aarons in the house. I hadn't realized that. You're absolutely right. There you go. Okay. Well, let's get down to business here. We're working on a second data competition, and we're working on the box plots for education competition. And I'll copy and paste the link into the chat window. And what we're trying to do is we have this data set. Let's look at the problem description. We have this data set where most of the features here are text, and then there are two numerical features. And what we're trying to do is we have all sorts of labels in this data set, like there are 9 different categories, and then for a total, there are what? 104 labels total. And what we need to do is we need to give a probability prediction for each of those labels. So we have this multi-class, multi-output problem. And what did we do yesterday? Well, we downloaded the data, divided our data into not train and test splits. Let's see here. So I'll go divide data into feature matrix and labels. There we go. And what we were in the middle of doing is we were in the middle of creating a model to make this all work. So what we did is let's see here, we uploaded the data, we divided it into a feature matrix and labels. And remember here in this case that not only is our X have multiple columns, but if we look at our Y, we also have multiple columns. So that's why it's multi-class, multi-output. And the first thing that we did is we looked just at the numerical features, and then that's what we're doing here in our column transformer. We're looking at only the numerical features, and we're filling in the values with the median. And from there, we fit our data, or rather, we were in the midst of fitting our data. I see Ricky from Nigeria is here. Welcome, Ricky. Good to see you. Ricky says that I love coffee like his dad. Oh no, Ricky's son says that. Absolutely. And Ricky's son, you should be very proud of your dad because he's learning and spending extra time outside of work to improve and do better in his job or whatever he wants to do. So he's a great role model. I see B and Zika is also here. Welcome. Okay, well, this is all fit. And if we do something here, let's look at the data. Let's look at the, let's see here. Let's prepare our submission. And in order to prepare our submission, the first thing that we need to do is we need to import our test data. So I'm going to go, let's see here. I'm going to go test data. What am I trying to do here? Let me think about this. I'm going to go test data. I'm going to go x test equals PD data frame read. Oh, wait, no, it's going to be PD read CSV. And it's going to be education test data index will equal 0. I think that should be it. Let's see here. And we'll look at the head. And I forgot a comma. Oh, excuse me. This should be index column equals 0. There we go. Now, here I have the data. Okay. And I'm getting two problems here. I'm saying columns 5 and 1 have mixed types. So column 1 is just a program description. And 0, 1, 2, 3, 4, 5 is also just objects. So what I can do is I can look at dtype. I'll put this on a new line. And I'll say, I'll have my dictionary. I wonder if I can do this by column names or just by column numbers. This is an experiment. I don't know if this will work. It does not work. Oh, and column 11 has mixed data types. Okay. So let's also let's see what 11 is. So I'll do df columns 11. That's subfund description, also an object. There we go. And what I'm going to do is, so first we've loaded our test set. And then next, I want to do predictions. So I'm going to scroll up to my one feature model, and I'll do one feature model predict X test, and I will save that as my Y prediction. And if we look at Y prediction, what data type do you think this is? What data type do you think this is? What am I getting back? Jobo thinks I'm getting a pickle back. Florin thinks I'm getting a pandas data frame back. Providence thinks I'm getting a percentage. Let's see. Actually, it's a NumPy array. Let's just see what the shape of the NumPy array is. Because remember that for people that answered a pandas data frame, keep in mind that scikit-learn doesn't automatically return a data frame when it's doing its predictions. It always returns a NumPy array. So that's the reason why we have a NumPy array here. And in this case, we have this prediction. It's 9. It's 9 long. It's 9 wide, I should say, and it's 50,000 long. If we look at X train, whoops, why is X train not there? Oh no, this is X test. If we look at X test and we look at its shape, we can see that it's 50,064. And we know that our labels, for example, if I look at Y shape, it's 9 long. So we know that this is doing every single column. It's predicting the label for every single column. Let's just see what it looks like for every single budget category. So I'm going to do Y prediction, and I'm going to look at the first 2 rows and all of the columns. And here we can see that these columns are all words. It's giving us what it thinks are the most likely categories for each, or the most likely subcategories for each category. So if we go here, what it's doing is it's going through each of these parent categories like function, and it's saying which one it thinks is most likely of all of these for that particular column. And that's how we're getting back a data frame. That's how we're getting back a data frame that is 9 columns wide, 9 columns wide. Now, if I scroll down to the bottom here, if I scroll down to the bottom, it says that my submission actually needs to be 104 columns wide. So what am I doing wrong here? What am I doing wrong? So Jobo says we excluded some columns previously. We did when we were training our model, but the issue is not what we put into our model. The issue is the output that we're getting. Let's look a little bit more closely at the instructions here. It says that our goal is to predict a probability for each possible label in the data set. So a probability for each possible label in the data set. And if we look at our predictions, we don't have a probability. We have the actual, well, we can call this the sub-label or the subcategory. So how can I get probabilities? I don't want the actual label. I want probabilities. Excellent. I see Maktumo1 has come up with an idea. Instead of using predict, I should use predict probability. Let's see what happens there. If I do predict probability, I go from 9 columns to, well, this is weird. I have a list. So if I look at Y predict and I look at the type, I have a list. And the length of the list is 9. So that corresponds to the 9 categories, the 9 subcategories, I should say, or the 9 parent categories. But what's in this list? I'm going to look at the first item in the list, and I can see that it is a NumPy array. And if I look at the shape of that NumPy array, I have 50,000 rows, and I have 37 columns, and those would correspond to the 37 different categories under the function supercategory, the parent category. So it's giving me these 37 rows. So the question is, how do I get this data frame? I have this list of data frames. What I actually want is one very wide data frame. I want a very wide data frame, this wide. How do I do that? I see Asif asking if there is a unit 3. There is not a unit 3, unfortunately. So Muhammad has the idea of reshape. The problem is, though, is that I have a list of data frames. I don't need to change their shape. I just need to put them all together. Excuse me, they're not data frames, they're NumPy arrays. So how can I stick them together, one after the other? I love this idea. Ricky has an idea of organizing a part 3. I love that. Actually, while I'm at this, while Ricky is bringing it up, one thing that I would request from you guys is you guys have taken Unit 1, you've taken Unit 2. If you know someone and you think that they would benefit from taking this course, recommend it to them. Put it on social media. Talk to your friends, talk to your people who have similar interests. I think this course is best when we have as many students as possible and as many applicants as possible. So, recommend to everyone that they apply if you feel like we're teaching things that are of value. So please recommend the course. I love this. So I see a lot of good ideas, and they all come back to the same idea, which is I need to do some sort of join. In this case, I can use, let me make sure I imported NumPy first. I'm going to scroll to the top. I'm going to import NumPy as NP. I'm going to scroll down, and then I'll do NumPy concatenate, and I'll pass in my Y prediction. And I want to join them side by side. So I should use axis. Should it be axis 1 or axis 0? Thomas is absolutely right. It's axis 1. So I'll call this my data. Florin says they should speak Romanian to recommend this course. Florin, speak any language you want. Just recommend it. All right. And so now I'll look at the shape of my NumPy array, and now I have 104 columns. Now I have 104 columns. And so now that I have these 104 columns, I need to look at the submission format, which I'll do right here. If I look at the submission format, I see that it's a CSV file, and I have all of these column headers along the top that I need to make sure that they fit. So I need to do exactly what Florin is saying. I need to make sure the names match the requirements. So let's look at this and see if we can figure out how to make this work. So, okay, what do I need? What do I need in order to get the names of the different categories? Where do you think I can find that information? So if I look at data columns, it's actually, there's nothing there because this is a NumPy array. It's not a data frame. But is there some part of our pipeline where our model examined the different possibilities for labels? For example, if we look at our one feature model, I'm going to look at my one feature model, and I'm going to look at the classes attribute, which are the classes that it's predicting. And if I look at the classes attribute, let's save this as my class list. And if I look at the class list and its data type, it's a list. And if I look at how many items are in this list, I have 9, which corresponds to the parent categories, the parent label categories. If you guys hear a garbage truck outside my house, it's because there's a giant garbage truck outside my house. Hey, I'm trying to teach here. Quiet down. And if I look at, say, the length, if I look at what's inside the list, let's look at the first item here. It's a NumPy array. And if I look at the shape of that NumPy array, I can see it's 37 long. So those correspond to the 37 subcategories that are in that first parent category. So what I have here is I have a list, basically a list of lists, where I have the 9 parent categories, and then for each parent category, I have another list with all the subcategories inside that parent category. And so what I need to do now is I need to figure out how to make this all work. I need to put this all into one flat list. So Florin wants to know how to recommend this course to people who don't know English but want to learn machine learning. I don't know. That's a tough one. Does anyone have any advice? Thomas has the idea of using some sort of concatenation, but here's the issue that we have. We have the class list. Let's call this the prefix list equals y dot columns. And what I have is I have this prefix list, which I want to then use to create column names where it'll be double underscore and then all of the subcategories associated with that. And I'm going to show you guys how I figured out this problem, and then I'll go over the instructions or how I did it. But the first thing that I did was I created a list called all columns, and I made it empty. And then I said for n, for number, in range, and then I said the length of y dot columns, so 9. I'm going to say all columns dot append, and then what I need to do is I need to use something called np vectorize. And what happens is this will take a vectorized function which takes a nested sequence of objects and returns a single NumPy array. And so what I did was I created a function. So I'll call this my vector function, and it's going to be np vectorize, and it's going to be a lambda function where I'm going to have the prefix and the column name. And what it needs to do is it needs to take the prefix string, add double underscores to it, and then add the column name. And so once I have that function, I can say do my v function for prefix list n and class list n. And so what will happen is that it will start with the first prefix, and then it will add that prefix to all the things, all the subcategories. And if we do that, and we look at all columns, we have a list. That list is still 9 items long, but if we look at the first array here, we can see that it has all of the proper formatting. And once I have that, what I can do is I can flatten this array. So I can go all columns equals np concatenate, and I'll say just concatenate everything in the all columns. And here, the axis is actually going to be none, because all of these are flat lists. So now, if I look at all columns, it's going to be 104 items long. And if I look at the first, say, 5 or 10 items, it's going to be these proper names, the proper column names. And everything is going to be properly aligned. All the names are going to match because we're working off of the same data. And once I have that done, I can go, let's see here. Submission equals, what is it that we were trying to do? Submission equals PD data frame, data, and then columns equals all columns. And I'll go to submission.head, and voila, here I have my beautiful table. And then the last thing that I want to do is I want to go, oh, the other thing that I need to do is I need to go index equals x, let's see here, index equals y, what is it? No, it's x test dot index. There we go. Beautiful. So now I have my proper data frame and I can save this. I can go submission to CSV and I'll do education and I'll put in a date marker and I'll do submission.csv. It'll take a second to save that all because it's a big data frame. And what I'll do now is I'll go to the competition page. I'll scroll up to the submissions and let me submit one here. Make a new submission. I'll choose the file. And I'll call this first submission numerical features only. And I'll submit it. Let's see how we do. And our score for submission is 14, which is not very good. We can definitely do a lot better, but the important thing is that it works. It works. So I'm excited about that. Okay, questions about what we've done here with our first prediction? So in this case, I think we're doing log loss. Yeah, multi-class log loss. And so the lower the better. So we're trying to get as close to 0 as we can. And right now we're at 14. Other questions? Well, how can we improve? Definitely what we can do to improve is we've only used 2 features so far. So we can improve by adding more features. Other questions? So I doubt that we've overfitted because we're only using 2 features. Probably we're severely underfitted. Now, before we improve our submission, what I want to do is I want to create a function called make submission, and you pass in the model and it will prepare the submission for you. So we're going to be doing this a lot. So we want to make sure that it's easy to do. So the first thing that I'll do is mostly I'm just going to copy and paste the text that we have previously. So we'll read the data into, so we'll say load test set. And then we'll do predict, where y prediction will equal our, not our one feature model, but in this case, just our model. And then we'll go, let's see here, prepare submission data frame. So I'll go data equals np concatenate. There we go. And we'll also do these other things here. We'll get the class list and the prefix list. And then we'll create the columns. I agree, Florin. You're definitely not talking too much. I think you are adding, there's no such thing as talking too much in class. That's what I think. There we go. And then finally, we need to have the actual submission. So let's see here. I'm going to do PD, what is it? PD date time now. Is that right? Yes, there we go. And then I'll go time. So I'll go PD date time, and then we'll do time from string. So PD time F string. Okay, sorry. String from time. There we go. And then we'll do format. Format equals, let's see here. Year, month, day. Oh, whoops, no, year, month, day. There we go. Underscore, and then we'll do hour and minute. There we go. Okay, beautiful. And so I'll call this date. I'll put this in here, and then I'll do submission to CSV, and I'll make this a format string. And then right here, I will drop in the date. Okay, beautiful. So this is done. Let's just see if it works. So I'm going to go, whoops, I'm going to go make submission, and I'll put in my one feature model. It'll take a second because it's a large data frame. And here I can see, here's my submission. Okay, so now what I can do is let's do another submission. Now, things are about to get complicated. Let's look at the data again. Let's look at the data. And here, what do we see? Do we see things that could help us? How do you think we should approach this? We already have our numerical features here. So if we pull up we have our data set, and we have our numerical features. And then we also have these, let's call them text features. With our numerical features, we're using our imputer, which is a kind of transformer. With our text features, we need to do something, and then we put them through our predictor, and that's how we get our predictions. But the question is, what on earth should we do with these text features? Jobo has one question. How can we handle NaN values? Well, if everything is text, what should we do with the NaN values? So Florin has an idea. We could replace it with the most frequent value here. What else could we do? Let's see how that would work. The other thing we could do is we could just simply replace with empty string. That's another idea. It's not necessarily a good or bad idea. Now, Stefan has the idea of filling NA with 0. In this case, we can't fill them with 0 because this is all textual data. So we don't want to mix in numerical data with our textual data. Let's try a few different strategies. The first is if we go to simple imputer, sklearn simple imputer, and Jobo has an excellent idea, like what do we do afterwards? Do we hash? We could drop them, but we'd be dropping a ton of rows, because if we look at x.info, we can see that we have 400,000 entries, and if I do x drop NA, just any NA, then all of a sudden I go from 400,000 rows to 0 rows. So there are NA values all over this. We need to do something with them. And I love what people are thinking. We need to do something here where we have a text feature. We need to do something where we need to fill NaN values, and then we also need to vectorize. And it's only then, once we go through those two transformers, that we can actually put it into our model. So maybe what we can do now is let's create our overall pipeline here. So let's say let's see here, we'll call this our all feature model. It's going to be a pipeline. And it's going to have some sort of column transformer. And it's going to have at the end, what were we using before? We were using a decision tree classifier. So let's just put that back in there. And I also need my column transformer. And I already know that for the numerical features, I want to use my imputer. The other thing I want to do is I also want my text features. So text features would be column for column in x dot columns if call not in numerical features. So if I look at text features here, okay, these are the text features. Beautiful. And so then what I want to do here is put my we're going to have to do many things. So this would be, let's call this our text pipe line. So we have our text features. And then the last thing that we need to actually do is we need to create our text pipeline. And we know that in our text pipeline, we're going to need some sort of imputer, maybe a simple imputer. And then we're going to need some sort of vectorizer. And I think that's what our full model would look like. So our text pipeline would be dealing with all the text features, and our column transformer would deal with the numerical features. And then we'll put it all together in a pipeline, which is our all features model. Now, Florian wants to know why our strategy is median. I think you suggested that yesterday. So I think that's why. But we can always change it. We can change it to mean. And so what we're going to have to do tomorrow is we're going to have to focus here on our text pipe and decide, one, what is going to be the way that we're going to impute missing values? And two, how are we going to um, deal with all of how are we going to vectorize this? That's the question. Now, Mohammed has a question in transformers. Mohammed wants to know why the number of features outside the bracket while text features is inside. That's actually not the case. It's just that the simple imputer has some brackets there, and so it just looks like that. But in fact, numerical features, here's the closing bracket, and text features, here's the closing bracket right at the end. So there's no difference. It's just that the simple imputer makes it a little bit harder to read. Okay, everybody. Well, this is what we're going to have to do tomorrow. Think about how we're going to deal with all of these text features. How is it going to work? And while you guys are thinking about that, I'll also be thinking about that. And if you have a chance and you're talking to a friend who you think might like data science, tell them to apply. I think that would be a great idea. And until we meet tomorrow, because it's the end of office hours right now, I hope everyone has a wonderful day or a wonderful evening or a wonderful night. And I hope your models train quickly. I hope your data is clean and happy, happy, happy data science. Thank you, everyone, for another wonderful office hours, and I'll see you all tomorrow.